So let me write a program. User will enter a character or enter an alphabet. Let me write like this. The character which will be an alphabet, maybe B, C or S. User will enter an alphabet. The program is to print all alphabets starting from that alphabet. That is, if user enters say S, you need to print from S to Z. So it is very simple. You can very easily tell the user. Firstly, you declare that character maybe you declare it I. You scan that from the user, printf, enter an alphabet. Very simple program, isn't it so? Enter an alphabet, and then what we do is, after you ask for an alphabet from the user, enter an alphabet over here, and then you say scanf %c ampersand I. You scan that alphabet character as a character from the user. Now from I, you have to now start printing. I is not to be initialized. I is already initialized. So from there till I is less than equal to 122, or maybe till it is less than equal to Z. You can write 122 also, or as a character Z, it's all the same, and I plus plus. You don't initialize means I starts from its value. Whatever value I is having, say I has been entered as S. So I starts from the S character, not S means S character. So I is the S character. So I starts from the S character from here and continues doing I plus plus till I less than equal to Z. This is possible because the characters are internally having decimal values. So user enters say B, B means it is having the value 98. So you are saying from 98 you keep on incrementing I till I reaches Z means till I reaches 122. So you keep on printing that. You simply printf %c what should I print? I should print I, because you are printing I as a character. So I is B. If I has been scanned as say E, then you start from IE. So you print firstly I means you print E, then I plus plus, I becomes F. So you print F. Actually internally E has been scanned means I is having a value of what? 97, 98, 99, 100, 101, E is 101. So 101 has been actually scanned. Scanned E means internally I is 101. So you start from 101, keep on incrementing till it reaches 122. So all from 101 to 122, all the numbers have been printed actually as characters in their character format. That is 101 is E and 122 is Z. So from E to Z, all characters will be printed. Let me run this program. Sorry. Okay, so this has to be definitely commented out before you run. So enter an alphabet. You enter maybe S. So see S, T, U, V, W, X, Y, Z. You can give that gap. Otherwise, it looks like there is nothing in between. So let me run it again. Say this time you enter E. So yes, E, F, G, H, I, J. From E you start and you print up to Z. It is very simple. A very simple program you are writing. And suppose this same program has been given to you. Say you need to print it, but one point you missed out, sorry, before you continue with some other format of the same program. See, you have written small z. What if it is given a capital letter? Then what will it do? Will you check out once? Say over here, instead of small s, I write capital S. See what happens. S, T, U, V, W, X, Y, Z. Then suddenly opening bracket, third bracket, then some other character, then this, then that, some other characters in between. Suddenly it starts from small a again and continues up to Z. Can you tell me why? All of you have guessed why. Because once you have entered S, S is having some value between 65 to 90. So starting from S, it continues S, T, U, V, W, X, Y, capital Z it reaches. And capital Z means it reaches 90. But you are not stopping over there. You are saying stop when it reaches small z. So after capital Z, that is 90, it increments again, becomes 91, prints that, what is that? say capital S, see this, prints, see after Z, 91, 91's equivalent character format is opening bracket, opening third bracket, so it prints 92's equivalent character format is maybe that slash, it prints 93's corresponding version is a closing bracket of closing third bracket, so it prints, so after 90, 91, 92, 93, 94 again prints that power symbol 94, it prints 95 an underscore, maybe 95's character format is an underscore, 96 its character format, maybe that that part you opening maybe an apostrophe sort of thing that you are seeing. Then comes 97, 97 is small a, 98 is small b, till you reach Z, that is 122. It keeps on printing all the characters. So you understand what is happening? This is what is happening. So if you want to stop that, if you print a capital that is over here, if you print capital S, you want only from capital S to capital Z and you want to stop there. What to do? Over here only I can check I less than equal to Z, or maybe you want to see, or is this I less than equal to capital Z, sorry, small I less than equal to capital Z, you can stop. But then again, there is a problem over here. I less than equal to small z, if you write or I less than equal to capital Z, then one small problem that may occur, see I suppose you have written small b, then small b, that is say 98. 98, is it less than equal to capital Z? No, it is not less than equal to capital Z. That means less than equal to capital Z in this case becomes false. So it will not print anything. Like over here, if I run this program, this will not work. Say I write small s, see small s to small z has been printed. If you write capital S, see capital S to capital Z, then again it has been it is printing up to small z again, because this or part you are wanting them to be fulfilled. So there is a small problem occurring. I think you understand this. If you write and, then see, if you write say small s to capital Z, now you run for small s, see what happens? Nothing is printed. It goes out. Why is it happening? Because when you are giving small s, your I is failing to satisfy this condition that it is less than equal to capital Z, because small s's ASCII value is greater than 97, so definitely it is greater than 90. If it is greater than 90, definitely it is not printing anything, because greater than 90 is a false and this is false and it is not printing. 97 greater than 90 is false, but 97 less than equal to 90, that 97 less than equal to capital Z is true. So that true and false makes it false itself. So it is not printing anything. So this way it is becoming very difficult to print. So how to print it? How to print it? How to print, say if it is capital A, then going up to that, if it is small a, then going up to that. Then you can do one thing, you say less than equal to end. What is end? End is another character. You decide the end at the beginning. Say when you scan this I, you just write if I is greater than 97 or greater than equal to 97, that is it is greater than equal to small a, then end should be equal to how much? Then end is small z. You see I greater than equal to 97, or else you can write I greater than equal to small a, anything you can write. I greater than 97, here you can also write I greater than equal to 97, or I greater than equal to small a, that is I falls in the small characters range. Then your end is the small z, is not it so? But else means I definitely, user has entered an alphabet, else means I falls in the uppercase characters. So in that case your end will be equal to capital Z. You have to continue till capital Z, and here you are doing exactly that. if I falls between, this is wrong, I greater than 97. If I is, say, I has been scanned, user has entered, say, small s. So small s means it is greater than equal to 97. Small a is 97, so small s is greater than 97. So you are seeing in that case end is small z. Else means it is not greater than equal to 97 means it is lesser than 97. It is lesser than 97 definitely means, say, user has entered capital S over here. Capital S is having a value between 65 to 90. So I less than 97 is true, greater than equal to 97 is false. So it comes over here, end equal to Z, capital Z. That means it is, you are treating capital Z as the end character. So in this case, printf %cci will print from capital S to capital Z. Let me run it once more. Say now over here I enter capital S. So capital S to capital Z. Now you enter small s, yes, small s to small z, it works absolutely fine. You can check out with other examples, small e to small z, you enter capital E to capital Z. So this program should work fine. I think you understand. One quick explanation once more. You have scanned this I. This I can be a small alphabet or a big alphabet. If it is a small alphabet, then its value is between 97 to 122. If it is the uppercase, then its value is between 65 to 90. Now what you are saying is whether I is greater than equal to 97. I is greater than equal to A means I is greater than 97, greater than equal to 97. So if I is greater than equal to 97, then you can say that you have entered the small character range. You are over here. That means your end point should be 122. That is what I have written. Your end point is 122. End equal to Z, you could have written end equal to 122. All the same. Is not so? Otherwise, else I is greater than equal to A is false. That means I greater than equal to 97 is false. So it is lesser than 97. So user has entered an alphabet means definitely it has entered something between 65 to 90. That is a capital character, uppercase character. So in that case your end is what? Not small z but capital Z. That is actually you are writing your end is 90 and you are printing those characters one by one. So your program is running absolutely fine. Your program is running fine like small r to small z, and you run with capital R, yes, capital R to capital Z. Your program runs absolutely fine. So I think you understand this. However, if you want to say change this program a little bit and almost the same, user will enter an alphabet to print all alphabets up to that alphabet. I think you understand. To print all alphabets up to that alphabet. That means if user enters small s, if user enters the lowercase s, all alphabets, up to that alphabet. See, to print all alphabets up to that alphabet. So in this example, what I mean to say is, if user enters small s, then your job is to print from A to S. However, if user enters capital S, then your job is to print from capital A to capital S. I think you understand this. So how to do this? Almost same. See, after checking this scanf, after this scanf, you can do the same thing. I greater than equal to small a means it has entered, user has entered anything between 97 to 122, that is anything between small a to small z, and else means it has entered anything between 65 to 90, that is between capital A to capital Z. So your start point will vary this time, not your end. Your end is always the character entered, but your start should vary this time. What is your start now? Here you should start from small a, and here you should start from capital A. I think you understand the logic. What I am trying to point out is, you may not look at all this, you may write the program yourself. This is highly possible. However, over here what I want to say is, I don't need the end character this time. This time I need the start character. Why do I need the start character? Because I have to start from where? Small a or capital A? That is the question. I have to start from small a and go up to the character entered, or I have to start from capital A and go up to the character entered. So this is the logic. So you should always start from the small a or the capital A. So your I, what I meant to say is, your I should always start from somewhere. So over here, how you can write this program? You can write this program that already I is containing something. What is your start point? You need to just think that logic. So you take j equal to, you start from the start point and go up to j less than equal to how much? Less than equal to I and j plus plus. See, do you understand my logic? I need a character j. I start from j as start. J to be started from either small a or capital A. How long should j go? J should go up to I. What is I? I has been scanned as small s or capital S. If I has been scanned as small s over here, then it is greater than equal to 97. In that case, your start is how much? Start is 97. I think you understand this. Your start is in that case 97. But else your start is how much? Capital A, that is your start is actually 65. So you start from that start variable, that is you start either from 97 or from 65 depending on which character has been entered, and then you go up to that character and keep on printing j. So it will be printed. You can run the program and check for once. Say you enter W, so small w, see A to small w. However, if you enter capital W, then capital A to capital W. You can say enter capital G, so it is capital A to capital G. However, you may enter small g, so small a to small g. So this program runs absolutely fine. I think you have understood this program. So before I leave this topic, and before I go to an array of characters in my next lecture, I will just point out another very interesting thing in front of you. For that, I will delete this program and show you another interesting part of characters. I delete this. So what will I do now? What will I do is, this is a new sort of thing that I want to show you. This is not actually a program logic that I am trying to show you. I am trying to show you no new programs I am printing. I am just trying to show you, if I add two characters, what happens. Say character A, if I say character A is, I assign it the value D. Then again character B, another character B is there. I assign it the value maybe E. And then I take a character C. What I do is, I write C is equal to A plus B. What happens? Two characters are added. Can you understand what is happened? Will D and E get concatenated and will you get DE? This is my question. See, my question is, A is D character, B is E character. When you are writing plus, will these two get concatenated and will you get DE? No, not possible, because C is a character. C is equal to A plus B. C is one character. It cannot have the value DE. It can have the value either D or E, but it cannot have DE value. So plus definitely will not concatenate this two. What will plus do? See, A is D means actually internally it has got a decimal value. What is the value of D? 100. What is the value of E? 101. See, D is A, B, C, D. So 97, 98, 99, 100. B is E, that is 101. Why? Because A, B, C, D, E. 97, 98, 99, 100, 101. So B is 101. So A plus B should mean 100 plus 101. C should have the value 101. So if I print that, what should I get? I should get the ASCII counterpart of this 100 plus 101, that is 201. So I can write printf %c, then C. It should be able to print the ASCII counterpart of 201. Let me run this program. See, 201's ASCII is this. How you can check it? You can check it like this. Change this A plus B, make it 201. Now you print C. You will see that 201 ASCII is printed. See that same old ASCII. You can change this and check for another example. Say this is small a, this is small b, the characters A and B, that is 97 and 98. So A plus B if I write, say if I write A plus B now, then 97 plus 98 makes it how much? 195. So if I print C, it is the character counterpart of 195 that will be printed. Let me run it. See, this is the character counterpart of 195. This symbol, you can see the symbol, it is the character counterpart of 195. How to check that it is the character counterpart of 195? Change this A plus B, make it 195, printf C, you see 195, this same old character will be printed. See this character. So I think you understand that addition of two characters, what happens internally, the decimal values get added, and whatever new decimal value is obtained, the character counterpart of that is printed. I think you understand this. Okay, so this is quite okay. One thing that I want to show you, suppose this addition exceeds 255. Say this addition has got a value of say 257, then what? Say if I print C equal to 257, then what happens? What happens if I print 257? Check what? The smiling face is printed, but you remember this smiling face is actually, if you print 1, it is this same smiling face. Why? Because 257 and 1 are all the same as far as characters are concerned. Because if you remember, I told you or I had shown you that 1 is what in 8 bits? In 8 bits, 1 is 0000, 0001. Is not it so? This is 1. If you want to represent 1 in character, this is 1. If you want to represent 257 in character, in bits, sorry, what is 257? 257 is 1, 00000001. This is 257. Why? Because this is 1, this is 2, 4, 8, 16, 32, 64, 128, 256. See, this is 256. 256 plus 1 is 257. I repeat again, this is 1. This is position 2, this is position 4, this is position 8, this is 16, this is 32, this is 64, this is 128, this is 256. So 256 plus 1 makes it 257. So this is 257, this is 1, but in 8 bits, this is 1. In 257 takes an extra bit. So when you are writing 257, how is it represented? 257 is represented with this 1 extra bit. However, these 8 bits are 1 itself. So it is taking it as 1 only. When you are writing 257, it is taking the last 8 bits itself, and last 8 bits makes it how much? Last 8 bits, check over here, makes it 1. So 257 and 1 are all the same. So if you print it again, see, sorry, this you need to comment out if you have to run a program. This is a problem. So yes, this part has to be commented. So see, if you run with this with 257, it is printing the same smiling face as that of 1. You can check with other examples, say 258. 258 will print the same smiling face which is for 2. Check out for 2. It is the same smiling face as 2. Why? Because you check out for 258. What is 258? What is 2 firstly? 2 is in 8 bits. Character is 8 bits, na? So 2 is 00000010. 2. Why? 1, 2, 4, 8, 16, 32, 64, 128. So this is 2. This is 2. However, if you write 258, 258, 258 is extra 1, then 00000010. Why? This is 2 and this is 256. This is 256 position. You can check out 1, 2, 4, 8, 16, 32, 64, 128, 256. So 256 plus 2 makes it 258. However, because it is taking character is of only 8 bits, so you can again check this 8 bits, last 8 bits are 2 itself. So that is why 2 and 258 are all the same. Is not it so? I am running with 2. 2 is that smiling face and 258 is that same smiling face. Is not it so? So even if your addition increases and becomes more than 255, it really does not matter. It will map it to the last 2 bits, last 8 bits. That is, it is actually divided by 256 and the remainder. Is not it so? 257 divided by 256, what is the remainder? 1. 258 divided by 256, what is the remainder? 2. So it is basically 256, it is the number divided by 258, the remainder. So even if it exceeds, doesn't matter. Check with y and z. Check with y and z. What is y? Y is 121 and z is 122. But here it is not exceeding 256, it is 243. So still it will print within, it is within 243, it hardly matters. So it is that sign. You can check with 243, less than equal to sign. You can check with 243, it is same. 243 is right. So check with this 243, see it's that same sign. I think you understand this, what I meant to say. Okay, so you can take a bit of break. When we come back, we will come back with character array, which we also call strings. We will introduce that. Thank you so much. Let's take a bit of break and come back.